let me start the recording first. Okay, so let's continue. So far we have seen what is a gravitational force, gravitational field strength, and also gravitational potential energy. So today we're going to look at a new subtopic known as escape velocity. Okay, so what is escape velocity? So obviously the name called escape. So it means it wants to run away from your gravitational pull. Okay, it wants to escape from the gravitational pulls. So in this, yeah, hang. So in this subtopic, what do we have to know? Now we have two equations that can be used to calculate the escape velocity. So I've shown you the derivations in the lecture, so I'm not going to mention it again. What am I going to do now? I'm just going to show you the equations and when to use the equations. All right, so there are two equations that can be used to calculate escape velocity. The first one is for you to calculate the positions of the object at any point above the surface of the planet. So I would say at any point, right? At any point. So the object initially, it could be on the surface of the Earth, or it could be at any point above the surface. So in that case, the escape velocity, now we use V with a subscript E. This E represent escape. So without E, it's just a simple velocity. It could be the velocity at any positions. Okay, so when it comes to escape velocity, you put a subscript E to tell the reader this is escape velocity. So VE equals to square root 2 GM over R. Okay, yeah, over R. Now, if you look at these equations, the U that GM, okay, the M that it used, the M that it used is a capital letter M. Means that it's actually looking at the informations about point mass. Okay, point mass means it is the mass that is not moving in our system. So which means it doesn't matter which object you're looking at. Okay, it could be a human, it could be a satellite, as long as you want to escape from the velocity from the gravitational pulls, then this is the velocity that you are going to use. All right, so it regardless of what types of object, they will all have the same escape velocity. Okay, they all have the same escape velocity. Now another equation is the equations that I would say they simplified it. So it could it can be used for only on the surface. Okay, when the object is on the surface of the planet of the Earth. So when object is being placed on the surface and it wants to escape from the gravitational pull, then you can use VE equals to square root 2GR. So this G, now because this one on the surface, usually we use it for the Earth. So this G actually is just 9.81. So R is the values of the radius of the Earth. All right. So basically, you see this whole equation is just a constant value. G is constant. Okay, G is 9.81 for when it is on the Earth. So G is 9.81, and then R is just RE. So it's fixed. So regardless of the object, okay, you can have maybe even your laptop. If your laptop, you want to throw it, you want it to escape from the gravitational pull, then what is the escape velocity? Then you use this velocity. Okay, and then this one. Okay, you just use the informations of the point mass. So in this case, the Earth is our point mass. Okay, this is our point mass. So basically, when it comes to escape velocity, test mass is not that important. Alright, test mass dia tak penting sangat bila kita tengok escape velocity. Kita fokus kepada point mass. So questions 1A. Calculate the escape speed from the Earth's surface for a rocket of mass 3000 kg. So this questions A, okay, is a bit tricky. Why? Because it gives you this 3000 kg. Okay, so I just told you just now, right? I just mentioned it. If you want to calculate escape velocity, you don't need the information about the point mass. And in this case, test mass is the Earth, is our capital letter M, point mass is the rocket. So you don't need the information about rocket. All right, so what are we going to do in the questions A? It's very simple. So VE now, since it says you place it on the Earth's surface, all right, let's try the second equations, which is equals to square root 2GR. okay, which is then equals to square root to 9.81, and then r given 6.4 times 10 to the power of 6. Okay, you calculate it and you should obtain 1.12 times 10 to the power of 4 ms negative 1. Okay, excuse me. So that is the answer for questions A. Okay, questions A, you have escape velocity, which is equals to 1.12 times 10 to the power 4 meter per second. Now, sometimes students ask me, can you use the first equations? Of course you can. Okay, of course you can, because you have the informations about the constant g, you have the informations of the mass of the earth, and then r obviously is the radius of the earth because you place it on the surface. Okay, so basically you can just try it. Okay, you can also try the equations one, see whether you can get the answer or not. Okay, but in class, I'm just going to show you one. Now, questions B. Questions B determines the kinetic energy of the rocket in part A. Okay, that must have a part A must have at the Earth's surface in order to move infinitely far away from the Earth. So determines the kinetic energy. Now it's asking for the kinetic energy of the rocket in part A. Okay, in order to move infinitely far away from the Earth. So you want to escape. So move infinitely far away means you want to escape. Okay, escape. You so escape. This is your escape velocity. All right, it wants to escape from the Earth. Wants to run away from our Earth. So how are you going to calculate it? Well, simple. Kinetic energy, we have K equals to 1 over 2 mv squared. Okay, that is the equations. So 1 over 2 mv squared. Now, since you want to calculate the energy needed to escape, therefore we use escape velocity. All right. And if you notice in these equations, I use small letter m. Okay, I use small letter m, which indicate that this is the mass of the test mass, the mass that is moving around, the object that is moving around, which is our rocket. Why? Because kinetic energy is about motion. The thing that is moving right now is the rocket. Therefore, this m should be small letter m, the m for point mass, but not for test, for test mass, but not for point mass. Okay, point mass is the Earth. The Earth is not moving, so there is no point in calculating the kinetic energy for it because the velocity is 0. Now, this escape velocity, it belongs to rocket. All right. So this k, you calculate it by using escape velocity. Therefore, m, you use the mass of the rocket. And because rocket is the object that is moving, the object that is in motion that has kinetic energy in it. So it is equals to 1 over 2. So the mass, we should use the mass from questions A. So 3,000. Okay, 3,000. And then 1.12 times 10 to the power of 4 squared. So eventually you obtain 1.88 times 10 to the power of 11 joule. So that is the answer for questions B, right? So now I give you 2 minutes to write it down, okay, including the equations on the right-hand side, because that is the only equations that we have in this subtopic. Okay, we have only these 2 equations in this subtopic, and it's very simple. So escape velocity basically is a bonus mark questions. All right, as long as you use the right mass, you don't go and use a wrong mass in your substitution, then you should be safe. So 2 minutes for you to write it down. All right. Now let's move on to the next questions. Now, next questions, a projectile. A projectile is fired vertically from the Earth's surface with an initial speed of 10 km per second. Neglecting air resistance, how far above the surface of the Earth it goes? So let's see. Now, this is the Earth, and then you want to fire a projectile. Okay, you want to fire a projectile. So a projectile. Initial speed given is 10 km as -1. So you have to be careful with the unit given. Given in terms of km per second, you yourself need to convert it into meter per second, right? So initial state, it is located on the surface. And then the final state, what happens at the final state? Now it asks you how far can it goes above the surface of the Earth. So now your projectile is located at here. Okay, so projectile is located at here. And what is the final velocity? Well, how far above means this is actually your maximum height. Okay, so if it is located at maximum height, if it reaches maximum height, then what happens? It means that at this position, V is actually equal to 0 meter per second. Okay, and then the height, this would be our maximum height. Okay, H max. Okay, now let's see how are we going to solve these questions then. Well, you have velocity and you want to look at the height. What can we do? Now, what we can just calculate it by using conservations of energy. Okay, so summations E initial is equals to summations E final. Okay, summations E initial is equals to summations E finals. And then, okay, and now what else do we have? Okay, so initials, we have K initial plus U initial equals to K final plus U final. Based on the diagrams that I sketched, based on the informations in my diagram, okay, V is equals to 0, which tells me that I don't have final kinetic energy. All right, there's no final kinetic energy. So I'm going to rearrange it again. So K initial is equals to U final minus U initial. Now, if you recall, what does it mean by U final and U initial? This one is actually our delta U. Okay, it is our delta U. So let's expand the equations. So 1 over 2 mu square equals to negative gm m and then a bracket 1 over r initial, r final minus 1 over r initial. So r initial and r final, how are we going to calculate it? Let's go back to the diagram. So remember, whenever we want to calculate r, we need the value from the center of the Earth. Okay, so this would be our r. So r for the initial state is just equal to capital letter R. R for the final state, because now it moved away from the surface. So R final is then equals to capital letter R plus H max. So these are the values that you want to sub into the equations. Okay, you sub it into the equations, then you should get the answer. But one more thing, now if you look at my equations, 1 over 2 mu squared, this m now is a small letter m, because the thing that is moving is projectile. All right, the Earth is not moving. So don't get confused between capital letter M and small letter m once again. Capital letter M is not moving. The thing that is moving is our projectile. So projectile, small letter m, we have it on the left-hand side. On the right-hand side, we also have the small letter m. All right, so this would make it easier for us by just canceling it out, because we are not given the mass of the projectile. Okay, but when it comes to these equations, you can actually cancel it out. So the remaining would just be half u square equals to negative g capital letter M bracket 1 over r final minus 1 over r initial. So now you sub everything, all of the value from the questions into the equations, then you should be able to obtain H max is equals to 2.55 times 10 to the power of 7 meter, right? So that is the answer for these questions. So these questions, even though it's called gravitation, but you need the concept from chapter 5. Okay, you need the concept from chapter 5 in order to solve it. So now it's a 17 past 2, I give you until 20 past 2 to write down the answer. You try to calculate to see whether you can get the answer or not, and also sketch the diagram. Make sure you understand why R initial is equals to R final is equals to R plus H max. How to obtain the H max. Okay. So 3 minutes from now, okay, I give you 3 minutes, try to calculate it, try to solve it. So if you cannot get an answer, then let me know. All right. So let's move on to the last subtopic in this chapter. Okay. So, yeah, where is my cursor again? Okay. Okay, now if you look at the learning outcome, derive equations for satellite motion. So derive, we have seen it in a lecture. Okay, we have seen it in a lecture how to obtain all these equations. Basically, it's coming from your chapter 6, right? Because you try to imagine what happens to the satellite. Now, if you shoot the satellite to a space, okay, so this is the Earth. So a satellite will move in its own orbits, okay, in its own orbits around the Earth. So which means it is also a circles around the Earth. All right, it moves in a circle. The reason why it can move in this circle, that is because of the gravitational pull. So that is a pulling force between them. So this is your Fg. Okay, this is your Fg. So when you look at, yeah, it's not capital letter G, small letter G. So if you look at this object, this diagram, satellite is moving in a circle, in a circular motion. So which means, okay, we can apply Newton's second law. So summations F equals to Fc, okay, which is equals to your MAC. So from here, we can then expand the equation. So the force that is causing my object to move in a circular motions, obviously, is the gravitational pull between these two objects. Therefore, Fg is equals to mv squared over r. All right, so when I expand the equation now, Fg, what do we have about Fg? Well, force, gravitational force is gmm over r squared. So which is equals to mv squared over r. So from here, what happened is that now we cancel out the small r. Okay, why small r? Now let's go back to the first equation. When we apply equations Fc equals to mac, the m that we use is the mass of the object that is moving in a circular motion. So obviously this small m is the mass of the satellite. Okay, it's the mass of the satellite because satellite is moving. Okay, it's moving in a circle. So the Earth is not moving in a circle. Satellite is. Therefore, the m in the first equation belongs to satellite, belongs to test mass. Okay, the mass that is moving. So this is our point mass, the mass that is not moving. So capital letter m's, we keep it in the equations. All right, and then what happens? What's next? We can cancel the r as well. So it becomes r. So rearrange the equations. So now you obtain v equals to square root gm over r. Okay, square root gm over r. Now this v is velocity. All right, don't get confused between all the other things. And from a v equals to square root gm over r, what happened is that now you want to calculate t, which is period, okay, not tension. So don't get confused once again. Period and tensions, both of them, they use capital letter T. So if you want to calculate period, what are you going to do? Now try to recall. T is equals to 2 pi r over v. Okay, 2 pi r over v. This is the equations. Period equals to 2 pi r over v. So basically, you just sub the v into these equations. So which is then equals to 2 pi r over square root gm over r. Right? So you want to move it up. It becomes 2 pi r times square root r over gm. Okay, flip it over. And now you want to move the r inside because now you have r. One is outside, one is inside. You want to move it in. So if you want to move it in, what should you do? Now this part, it has a square root. Okay, so r is actually equals to square root r squared. Therefore, the final answer is just equals to 2 pi square root. Now r times r squared, we have r cubed over gm. So that is period. Okay, that is period. So velocity and period, that is the only things that you want to calculate in a 7.3. And I can tell you, this subtopic, it comes out almost every year in your exam. All right. So in past 10 years, if no 10 times, then at least we have 9 times that we have questions come up from this subtopic. Okay, about satellite. So make sure you know how to use these two equations. And if you notice, the m that we use in the calculation is a capital letter M once again. Okay, once again, it's a capital letter M. It's not the small letter m. So which means the mass of the satellite is actually not important in our calculations. What we want is just the informations about the planet, about the point mass. Okay, so V and T, now you have the equations, and then these two equations will be given in the exam. So basically, you just need to apply them. Okay, you just need to apply it. The only things that you need to be careful is in terms of the R. Okay, the R always coming from the center, but questions, it likes to trick you. Okay, it always tells you it's from the surface. So if you use wrong R, then against, okay, the whole questions will be gone. Okay, now let's look at the questions number 1. Okay, questions number 1. A satellite travels at height of 150 km above the surface of the Earth. Now you see, 150 km above the surface. So which means this is just H. This is not your R yet. Okay, this is just a H, and it is in terms of km, if you notice. So determines the velocity of the satellite. So questions 1A, what are we going to do? Well, you want to calculate V. In order to calculate V, you need R. So R is equals to H plus RE. Okay, which is then equals to 150 times 10 to the power of 3 meter plus 6.38 times 10 to the power of 6 meter. Okay, which is equals to 6.53 times 10 to the power of 6 meter. So this is the R. Okay, this is the R. Now, once that you have R, you can then determine the velocity. So V is equals to gm over R. G is a constant value, M is a constant value given in the questions. Okay, and then R is We calculated already. So you plug everything into the equations. Eventually, you will obtain 7.82 times 10 to the power of 3 m as negative 1. Alright, kamu sendiri substitute and then tekan calculator, see whether you can get the answer or not. And then questions B, the period, you see, just velocity and period. Very direct questions. That's why chapter 7 actually is very easy. As long as you don't make any mistake in calculating the R. Right? So if you look at the past year question, if I'm not mistaken, it's the last year or a year before. Right? The question is very tricky. Chapter 7, they have questions A, B, C. All three questions, they use the same R. So if you got the R wrong in questions A, then basically I don't have to mark your questions B and C. Definitely you're going to get it wrong. All right. So R is the most important thing in chapter 7. Once you got it wrong, basically I don't have to look at the following questions because all of them will be wrong. Okay. So now let's look at questions B. Questions B, just now we derived the equations already, which is T equals to 2 pi square root R cubed over GM. Okay, R cubed over GM. So again, plug everything into the equations. Now you have all the informations. So plug it into the equations and eventually you will obtain 5.25 times 10 to the power of 3 second. Okay, 5.25 times 10 to the power of 3 second. So this question is a very simple question, all right? Just make sure you don't make some careless mistake, especially in calculating the R. So as you can see here, questions A, you need to use R. Okay, you need to use R that is equals to H plus RE. Questions B, also you need to use the same R. So if you got it wrong in questions A, basically there's no chance for you to get the correct answer in questions B. And I don't even have to mark your questions B. Straight away, I can give you 0 mark. All right? So be extra careful with the R. Okay, so this one, this one is a bit long because I want you to write down the derivations as well. So I give you 5 minutes. Okay, I give you 5 minutes, including the time for a short break lah, we said. All right, so you write it down, then you can get a short break. And before we continue to the next questions. So we are done with 3 questions, 3 more questions to go to finish off the chapter 7. All right, so let's take a short break, 5 minutes break. So this 5 minutes, you write down the things on the slide, and then so you can go and have a drinks or go to washrooms. Okay, so continue again at 2:35. All right, 2:35. Okay, so let's continue. Now, if you look at questions 2, this question, it requires a bit of a, I would say a bit of a language. Okay, you need to understand BI a little bit. So the satellite travels at a height which is twice the radius of the Earth. So it is at a height which is twice the radius of the Earth. So what does it mean? So now you have the h, which is equals to 2re, okay, from the surface of the Earth. So which means now this is the Earth, right? And then you have a satellite. Okay, you have a satellite. Where the satellite is located at a h that is equals to 2re above the surface. Okay, above the surface. So what does it mean? So it means, okay, when you do a calculations, you need to take into considerations 3re, because your r is equals to 2re plus re, all right, which is the h plus re. So which r is equals to 3re. That is the r that you need to use in the calculations. So it wants you to determine the periods, okay, the periods of the revolutions of the satellite. So how to calculate period? Again, we have t is equals to 2 pi square root r cubed over gm. So from here, you can then plug in the information. So these questions, students sometimes they cannot answer it. Why? Because they don't know how to get the correct r. They don't understand what does it mean by at a height which is a twice the radius of the Earth. Okay, twice the radius of the Earth means 2 times of the radius. So, so r that we're going to use is r equals to 3re. So it is equals to 2 pi square root. Aha, now this part you have to be careful. Cube, you don't just cube the r, you have to cube the whole thing. 3re. And then you cube it, including the 3. So over gm. Okay, over gm, which is then equals to 2 pi square root. Now, if you cube 3, then we have 27 re over gm. Okay, 27 re over gm. So from here, you can then obtain the value 2.63 times 10 to the power of 4 second. Okay, so that is the answer. So I give you 3 minutes to write it down, all right, including the diagram. Make sure you sketch the diagram so that you understand what does it mean by twice the radius of the Earth, and then how to do the cube, okay, how to cube 3r. All right, this is a very crucial part in this question. Sometimes students got it wrong. Why? Because they just put cube on re. They forgot about the 3. So 3 is very, very important. You need to cube it as well, all right? So 3 cube r cube, and then you obtain 27 r on. I miss out a cube here. Okay, cube. Then from here, you just calculate the value. So 3 minutes for you to write it down. Okay, you calculate it. So remember to sketch the diagram ya. Sebab memang masalah paling besar dalam soalan ini pelajar tak faham. All right, so make sure you take notes here, the diagram and also the part that I highlight. So this is a common mistakes that we found in the exam. Okay, now let's look at questions number 3. So the periods of the moon it takes to revolve around the earth is 27.3 days. Okay, so for a moon to complete one revolution around the earth is 27.3 days. And then the average radius of the earth is a 6.37 times 10 to the power of 6. The gravitational field strength on the surface of the earth is a 9.81. Determines the average distance between the moon and the earth. Now, these questions, okay, it just want to make you confused by using a lot of I would say not the terms that is not needed. For example, the average. All right. So basically, let us analyze it one sentence by one sentence. The period of the moon takes to revolve around the earth is 27.3 days. So this 27.3 days is actually our period T. Okay, but T, since we want to use it in our calculations, so we need it to be in a second. So 27.3 days, okay, 1 day is how many hours? 24 hours. 1 hour is how many minutes? 60 minutes. 1 minute is how many seconds? 60 seconds. So times 24 times 60 times 60. So it is equals to, let me calculate. 27.3 times 24 times 60 times 60. So I have a 235x720 second. Now I can leave it like this first. It's fine, okay, because this is not the final answer yet. Just the final answer. I need to write it in power form, in the prefix form. Okay, but before you reach the final step, it is up to you how you want to display your answer. So T is equal to 235x720 second. Or you can even keep, okay, or you can even keep this part first. Okay, kalau kamu tak nak kira, kamu nak keep part ini, tak ada masalah juga. Alright, this is just for your own notes. So before you reach your final step, it is up to you how you want to display your answer. And then let's look at the second sentence. The average radius of the Earth, basically what it wants to tell you is that this 6.37 times 10 to the power of 6, it is your RE. Okay, so don't be fooled by the terms average. Okay, don't be fooled by the terms average. What it means is just the radius of the Earth is 6.37 times 10 to the power of 6 meter. And the gravitational field strength on the surface of the Earth. So now what do you have? Okay, you have AG equals to GM now over this R. Why I want to write this equation? Because it mentions in the questions on the surface. So there must be a purpose. So it's over RE. Okay, I substitute the R first. So square, which is equals to 9.81. So there must be a reason why it mentions the gravitational field strength on the surface. Okay, so I write it down first by using RE. So next one, it asks you to determine the distance. So don't be fooled by the terms average once again. What you want to determine is just the distance between moon and the Earth. Okay, so you want the R. Okay, you want the R. So how are we going to calculate then? So let's see. I have period, I have R, I have AG. Okay, so AG, if you look at AG, what can I do? Now I can rearrange the equations so that it becomes GM equals to 9.81 times RE squared. Okay, times RE squared. So R.81 RE squared. Okay, so this is the values for GM because we are not given the values of M. Okay, kita tak ada nilai M. So what we can do is GM equals to 9.81 RE squared. Okay, so let's leave it first, and then we have RE. Okay, so you can actually calculate it. Okay, you can actually calculate it. 9.81, and then RE is a 6.37 times 10 to the power 6 squared. Okay, so this is what you can have. Okay, so the remaining part that I can use is the period, the T. So let's try it. Okay, let's try it. So T equals to square root, oops, my 2 pi is missing. 2 pi square root R cubed over GM. Okay, the reasons why I use this equation, because this is the only equations that I can use to determine the distance R. Okay, I can use to determine the distance R, only these equations. I cannot use RE to determine R. I cannot use AG to determine R. Why? Because it already tells you this AG is just for RE, but it's not for small letter r. Okay, that is a small difference between these two R. Capital letter R and small letter r, they mean different things. So small letter r is the distance between moon and the earth. Capital letter R is just the radius of the earth. All right, so now you have a case where this is the earth and then this is the moon. Okay, this is the moon. So I have RE is just here. Okay, RE is just here. But now what we want to calculate is from here until here. Okay, this is our small letter r. So you have to be careful with all this quantity, okay, all these variables. So capital letter R, we have the value. Small letter r, we don't have. And now we want to calculate the distance between the Earth and the moons. The equation that is suitable is period. All right, because AG is not suitable. AG already tells you now you are using it for object that is on the surface. Okay, for object that is on the surface. So we don't want on the surface. We want the information about the moon. Therefore, we use period. So how do I know that I can use period? Well, because you are given the period of the moon. Therefore, you can use it to calculate the R. Okay, so let's see how are we going to solve it right now. So T, I have this value. So 2358720 equals to 2 pi square root, okay, square root R cubed over, now my GM now is equals to this value. So 9.81 times 6.37 times 10 to the power of 6 squared. Okay, so this is the equation. So rearrange the equations and then you use your calculator to calculate. You should be able to obtain R equals to 3.83 times 3.83 times 10 to the power of 8 seconds. Okay, times 10 to the power of 8 seconds. So that is your final answer. So this answer, this question, it tests your understanding, whether you can understand the questions or not, right? And whether you are familiar with the equations or not. So if you use AG, then what is the R? If you use T, then what does it mean by this R? So T period, since you have the period of the moon, so the R that we are using is the R between moon and earth. For A, we use capital letter R. Why? Because it mentions the term on the surface. So all these terms, even though it looks like, well, just a simple terms in the questions, but it carries a hidden meaning there. Okay, dia ada maksud hidden. So kalau anda tak faham maksud hidden dia, anda memang tak boleh jawab. Alright, so be careful with the R. So the things that I highlight, you need to know. Okay, now I'm going to highlight with a different color to make it clearer for you. So this one belongs to this one. Period of the moon, it tells you your R is a small letter R. Okay, so small letter R, I have diagram here. And then the yellow color on the surface, we use it for AG. So AG, the R is here. So different term, different equations for different positions in the diagram. All right, it represents different positions in the diagram. So the reasons why I use period, that is because what I want is the informations in green color. Okay, so now I give you, wow, this one is quite complicated. I give you 5 minutes. Okay, I give you 5 minutes. Try to understand the whole question, sketch the diagram, and then complete the calculations. Okay, soalan ini dia memang rumit sedikit. Well, I can call it hot questions. So make sure you understand it. I give you 5 minutes to sketch the diagram, to do all the calculations, to do all the highlight things. Make sure you know what is the difference between capital letter R and small letter r. If you have any questions, okay, you may ask.
Madam,
Yep.
yang R tu dia kena dalam meter kan?
R kena dalam meter. Saya tak tukar ke? Aha, okay, saya nampak masalah dia. Thank you very much. The last one. Saya ditipu oleh answer di sini. Ini this is meter. Okay, thank you very much. Okay, so soalan ini boleh faham kan? Alright. Saatnya saya ada message masuk. Kamu cuba soalan seterusnya dulu. Okay, see whether you can answer the next question. Next question is a very simple questions and it is a typical exam questions. All right, so let's see the last questions. Okay, the last questions. Now we're going to take a short break again, and we are going to continue with your UPS. Okay, so 500 kg satellite orbiting the Earth at a radius of 6,890 km from the surface of the Earth. So these questions give you a 6,890 km with at a radius of at a radius of 6 from the Earth's surface. Now from the Earth only, okay, not from the surface. So a 500 kg satellite orbiting the Earth at the radius of 6,890 from the Earth. So find the satellite orbital speed. So this value given straight away is the R already. Okay, is the R already. So questions A, the satellite orbital speed. So orbital speed is a V. Okay, satellite orbital speed is V. V equals to square root GME over R. Okay, so R given is 6,890 km straight away. So this is not the distance from the surface. This is the radius from the center of the Earth. So it is equals to, okay, so you have a ME already, and then you given R, you're given G. Basically, you have everything. Just press calculator, straight away you got 10 to the power 5.8 times 10 to the power 7, ms negative 1. Questions B period, once again, you have all of the informations already. So 2 pi square root R cubed over GM. Straight away you got 5680 seconds. Question C, gravitational force acting on it. F equals to GMM over R squared. Okay, F equals to GMM over R squared. So your given satellite mass is 500 kg. This is small letter m. So you have a small letter m, you have capital letter M, you have R, you have G. Straight away you got the answer again, which is 4215 Newton, right? So this question is a typical exam questions, and usually just these 3 questions, it worth 6 marks already. So questions 1 usually is 2 marks, this one 2 marks, this one 2 marks. All together 6 marks. So you see, it's very easy to score in your exam. Okay, just use the right equations and make sure you use the right R and the right M. Okay, and the correct M. Now, another terms that you will see in the exam, okay, in the past year questions, is altitude. Okay, what does it mean by altitude? It means the height from the surface. Okay, height from surface. So this term, it came out in a past year exam, I think 2 years ago. All right, so almost 50% of the candidate, they don't understand this term. So if you don't understand the meanings of altitude, then there's a very high possibility that you couldn't answer these questions. Okay, so altitude means it's above the surface. So I give you 2 minutes to write it down, and then we will proceed to UPS questions. Okay, let me find the UPS question first.